ever spun a fresh egg and notice how difficult it is to spin? Well, this is because of inertia, the property of all objects with mass that allows them to resist a change in motion. However, if I try to spin a boiled egg, notice how easier it is to spin, and it even spins faster. So, why is there a discrepancy in the observation? Well, to understand this, we need to know what happens when we spin the egg. Let's find out. In a boiled egg, everything is hard. The yolk of the egg is fixed in one place. When I spin the boiled egg, everything inside of the egg spins at the same rate, including the yolk. However, for the fresh egg, the yolk of the egg doesn't spin at the same rate as the shell, and this is because of the yolk's inertia. Since the egg white is loosely connecting the yolk and the shell together, it doesn't allow all the force that I'm trying to rotate the egg with to spin the yolk. To illustrate this, let us use this setup. Let the white bowl be the shell of the egg, the water inside of the bowl be the egg white, and the white cap inside of the bowl be the egg's yolk. When I attempt to spin the bowl quickly, notice that the white cap doesn't spin instantly. And this is exactly what happens when I attempt to spin the fresh egg. But as the bowl slows down, the white cap starts to spin at the same rate as the white bowl. If I use oil instead, the white cap will start to spin at a higher speed compared to when water was used. This is because oil has a higher viscosity, or in other words, a higher thickness compared to water. What do you think would happen if I use a liquid with a lower viscosity? Comment down below. So because the egg white is very thick, it allows the yolk to spin, but not as fast as I'm trying to. In addition to this, because of the yolk's inertia, it resists being moved. Since inside of the boiled egg is hard, I am going to stick the cap onto the bowl. As you can see, when I spin the bowl, the cap spins at the same rate as the bowl. This is because the cap is firmly connected to the bowl, just as the yolk and the egg white inside of the egg is firmly connected to the shell. So there you have it. This is why a fresh egg spins slower than a boiled egg. I could end the video there, but there is another interesting consequence of everything that I've just explained. When I spin these two eggs, notice what happens. This is the fresh egg. As you can see, after I stop the egg, it continued to spin when I remove my hand. Now, this is the boiled egg. As you can see, the egg remained at rest. When I spun the egg, the yolk inside of the egg would have started to spin as well. When I attempted to stop the egg, because of the yolk's inertia, it would have continued to spin inside of the egg. When I removed my hand on the egg, because the yolk was still spinning, it allowed the entire egg to resume spinning. However, for the boiled egg, because everything inside of the egg is hard, when I stopped it, everything stopped. Hence the reason why it remained at rest when I removed my hand. We could use the same setup to illustrate this observation. So, this is the spinning egg trick. I hope you've enjoyed this video and learnt about inertia. I have a challenge for you. Can you think of any instances in the real world where the principle of inertia is applied? I have one. That jerk you feel when a vehicle suddenly brakes or accelerates very quickly is because of your inertia. Thank you for watching. Please like the video if you liked it, subscribe and share.